This is a kit for determination of numerical aperture model FOT100A. We already discussed the circuit diagram and components available in a kit. So now I am going to perform the practical. We are going to choose first 2 kilohertz input, then ground, okay. Now fiber, this is a fiber connector, LED 660 nm, okay, and switch on power supply. Okay. See, there is a light from my fiber. I'm going to off this power supply, no light. Again, I'm going to on this power supply, there is a light. First question, I hope everyone is curious about that. If this is a TTL 2 kilohertz or if you change this TTL 1 kilohertz, light is continuous. Okay, actually the 1 kilohertz or 2 kilohertz light, but the delay is very small, so that's why the delay for on off of a light it can't determine by my eyes. Okay, that's why it is a continuous light. Okay, so light is on. Now this is a scale is given to measure. I'm going to put this fiber in stand till end. Okay. Here is a blank paper. For experiment we can use graph paper. For demonstration purpose I am using this white paper. Okay, if you can see, if I am changing the distance, the focus is changed. If I decreases the distance, then it is a narrow, and if distance is increases, it is going to be broaden. Okay, now we want to perform the measurements. So my distance is a 1 centimeter first reading. Okay, and focus in a 4 direction. I am going to mark that. Okay, now my distance is a 1.5 centimeter. Now mark this. Okay, now my distance is 2 centimeter. For demonstration purpose only I am using a sketch pen. When you are performing a practical, please use pencil so the nib is sharpened and your readings are very accurate. Okay, now switch off kit. Now I am having 3 circle. First, second and third. Okay, from middle I am going to draw this point. Okay, measure here to here distance. Then R to M distance. R to N distance, R to O distance. Okay.
For more information of this topic, don't forget to subscribe my channel Pinnacle.